Hello, good afternoon. Now it's time to begin the webinar. First of all, thank you so much for joining to our webinar for dust measurement technologies. My name is Maeda. I'm responsible for overseas department and marketing department at Matsushima Measurtech. Today, I will be hosting this webinar and also present the first session for dust measurement technologies. Before starting the webinar, I'd like to tell you some precautions. Your microphone is muted during the webinar, so please use Q&A column on the right side of the screen if you have any questions. And questions are welcome at any time. You can send a text on the Q&A column at any time. And we will have the Q&A session at the end to reply to your questions. If we do not have enough time to reply to your question during this webinar, then we will send an answer later by separate email. Who is Matsushima Measurtech? Please let us introduce ourselves briefly in a short time. We are the solution provider for measurement and monitoring applications, mostly in heavy industries like steel, cement, power plant, non-ferrous metal, fertilizers, chemicals, food, mining, blah, 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 blah. And main products and services is those 5 ranges. One is level sensing. We have radar level transmitter and some various level switches for mostly for powder and bulk solids applications. And next one is dust sensing technologies. Today we will be focusing on these technologies, including some general informations. And we also have safety sensing. We also have robot systems, including human collaborative robot, especially for automotive industries. Regarding network, we have subsidiary company in China and South Korea. Regarding distributors, we have a partner company in Taiwan, Indonesia, India, Thailand, Malaysia, Vietnam, Philippines, Australia, Mongolia, Russia, and US. Okay, this is today's topics. First session is for dust measurement technologies. I will provide this information today about kinds of typical dust measurement technologies, features of each those technologies, and what is the most effective way on the viewpoint of productivity improvements. And second session will be provided by Mr. Mamoru Omura. He will be focusing on triboelectric principle dust monitor and new product air dust monitor. Then after this session, we will answer to your questions. We do hope our webinar will be useful and helpful for your activities. So let me start the first session, dust measurement technologies for productivity improvement and environmental solution by continuous dust leak monitoring at dust collector. I have one question. How do you monitor the dust leakage from your dust collector in the plant? How do you monitor the dust leakage from your dust collector in the plant? There are some technologies to monitor about this, but how do you monitor in your plant? These are typical measurement methods that I'm going to explain later one by one. The first one is visual checking. This is principle is just looking by human eye. Human eye is flexible, but personally I have some problem on my eyes. But anyway, it's probably not so accurate. Second one is manometer. This is a differential pressure system to detect if the filter bag is broken. The third one is isokinetic analysis. This is the manual measurement method based on environmental standard and generally should be done at least once every few months according to government regulations. Next one is periodical filter replacement. We can say it's a kind of preventive maintenance, and it's the way of replacing filters periodically before it breaks. The last one is continuous monitoring with dust monitor. Uh, this is an online real-time measurement for dust concentration. And dust monitor system is the only method providing continuous real-time monitoring. So what about your plant? Which dust monitoring method do you use in your plant? This is the result of our survey we've done in July with our Japanese customers. It seems the visual checking is about 30% and the most popular method. Next one is number 4, periodical filter replacement, and it's about 23%. So it means over half of them does not install any monitoring equipment at the facility. Actually, I'm a little bit surprised about this result. I thought the figure for continuous monitoring should be a little bit more. Anyway, I will explain the basic principle and the feature of each method from now, and hope this will be helpful to you for finding the best way for your situation. The first one is visual checking. Principle is quite simple, just looking by human eye. Of course, it's the most cost reasonable method, but the problem is that dust has already leaked out and gone above the regulation point when you notice by your eyes. I feel it's a little bit risky, and we do not recommend this, especially for such plant located close to human living area. Second one is manometer. Principle is differential pressure monitoring system. This system can detect filter bag breakage situation because the internal pressure of the bag filter becomes same, and there is no differential pressure exists when the filter bag breaks. So we can say it's reasonable for broken bag detection, but it is not so sensitive and not accurate for dust leak amount variation. So there is a certain risk to emit much dust in the air. Next one is isokinetic analysis. This is about manual measurement in accordance with environmental standard or government regulations. Some of you probably ask some environmental measurement company for this measurement. If you have such a big stack, that should be monitored under government regulation. This is such a manual measurement, so of course that's not possible to get real-time data. And there is big risk to emit much dust in the air. Next one is periodical filter replacement. That's to say replacing filter bag periodically much earlier than it gets damaged. So I can say this is a good solution on the environmental viewpoint, but it costs too much. For example, filter bag cost, maintenance cost, those costs may become unreasonably expensive. The last one is continuous monitoring with dust monitor. I said the periodical filter replacement is a kind of preventive maintenance. But I can say this continuous monitoring with dust monitor is, we can say, predictive maintenance method. And there are many benefits. For example, it can prevent environmental damage by detecting sudden leaks because this is continuous real-time monitoring method. And also it can contribute to labor saving because it's continuous real-time monitoring sensor. And you can save a maintenance cost because you can use filter bag until its maximum lifespan, because this can provide the continuous monitoring. But one problem for this sensor is that all those dust monitors are relative value measurement devices. So it may be worrisome to decide an appropriate threshold value of those sensors maybe. This is the comparison chart for those 5 typical measurement methods. This presentation file will be provided by email later for those people who answered the questionnaire we will send you after this seminar. So please answer to the questionnaire and then review this document later in detail after the webinar. What I want to say, please kindly answer to those questionnaire. It takes only a few minutes. Anyway, now I believe most of you have already noticed what is the best way for dust leak monitoring. Yes, we do recommend continuous monitoring with dust monitor. For such specific dust containing harmful substance, sometimes periodical measurement with isokinetic analysis is required by regulations. But anyway, it is obvious that continuous real-time monitoring will be safe and beneficial. So both cases for such harmful dust or general dust, we can say continuous monitoring with dust monitoring is the best effective way for like a productivity improvement and also safety reason. In conclusion, again, the best effective way is continuous monitoring with dust monitor, and its benefits are in the following. First, it can prevent environmental damage because it's continuous real-time monitoring and can detect even small dust leak variation. Second, it's simple. Because it's continuous monitoring, it can supplement intervals of isokinetic analysis. The last one is labor saving and cost saving. You can achieve predictive maintenance with dust monitor. Here at the last part of my session, I show you the kinds of continuous measurement dust monitors. There are 3 typical principles. For example, in Japanese Industrial Standard GIS, we have Z8852 standard stating 3 kinds of continuous measurement methods. 2 of those 3 are optical principle. One is light scattering system, and the other one is light transmission system. And the last one is triboelectric principle. We, Matsushima Measure-Tech, has this principle dust monitor. Omura-san, Mr. Omura will explain in detail about this triboelectric dust monitor later in his session. I'm going to explain the brief principle for those 3 one by one. First one is light scattering principle dust monitor. When the measuring light is irradiated to dust flowing the pipe, the light is absorbed and scattered. In this situation, the scatter light intensity is measured because it is correlated with dust concentration. So the principle is based on the correlation between dust concentration and scattered light from dust. Next one is light transmission principle dust monitor. When the measuring light is irradiated to dust following the pipe, it is blocked by dust and the original light is attenuated. In this situation, the measuring light intensity is measured because it is correlated with dust concentration. So it means the principle is based on the correlation between dust concentration and light attenuation from transmitter to receiver. The last one is triboelectric dust monitor. When two solids comes into contact, electrical charge transfers between them. This charge transfer is known as friction static electricity or contact charge. Similarly, when the particles flowing in the pipe contact or pass through the electrode probe, induction phenomena occurs between the particles and the probe. In this situation, this transferring electrical charge is measured because it is positively correlated with the dust concentration. So the principle is based on the correlation between dust concentration and the amount of friction static electricity. This is the comparison chart for those three types of continuous measurement principles. Correlation efficient against absolute value for all those three principles are over 0.9. It means we can say all of them are almost correlated with absolute value. Advantage and disadvantages of those three is shown on the chart. Regarding cost, triboelectric system is the lowest. And the advantages of triboelectric system against optical principle will be presented by Omura-san later in his session. At the last, I have to tell you one very important thing, very important. Actually, I am aware that many people believe optical system is absolute value measurement, but this is wrong. This is wrong. Only the isokinetic analysis is absolute value measurement system for dust concentration. And all the other continuous monitoring system, including triboelectric and optical system, is relative value measurement. Optical system is not absolute value measurement. This is important. Thank you so much for your attention for my part dust measurement technologies. I have presented 5 kinds of typical dust measurement technologies and 3 kinds of continuous monitoring method principles. It will be really greatly appreciated. This my part is useful and helpful for you to finding some best effective way for your situations. For your questions received in this session, we will answer those questions at the end after Mr. Omura's sessions. So, okay, Omura-san, I will switch the screen to you. So please proceed your sessions. Just a moment.
Thank you, Mr. Maeda. I'm Mamoru Omura, working for the export team in Matsushima Measure-Tech. In the first session, Mr. Maeda explained the filter monitoring method and 3 types of the dust sensor. In second half, let's have a chance to introduce Matsushima products. One is a dust monitor. Second one is a new model, air dust monitor. First one is a dust monitor. Dust monitor is installed after the dust collectors and continuously monitors the filter's condition. When it detects the dust leakage, it gives the alarm signal to stop the operation and exchange the filter before dust emission. It is one of the online sensors triboelectric type dust monitor. Mr. Maeda explained there are 3 types of the online dust sensor. light scattering type, light transmission type, triboelectric type. Why Matsushima selected dust triboelectric type dust monitor? Because one is a special technical knowledge is not required. One is a easy maintenance and also low prices. If the customer has never used a dust sensor, we strongly recommend our triboelectric type sensor because no special technical knowledge is required, easy maintenance, and low prices, which means the initial low cost and low risk. If the customer has some technical, maintenance, or price issue of the existing sensor, we also recommend replace our triboelectric type dust monitor. At this slide, we will review this principle of triboelectric type sensor by animation movie. I will switch to the movie. Our dust monitor measures the electrical charge from dust particles. Under the normal condition, it measures the small concentration and outputs the lower value. Once the bag filter is broken, more dust flows through the sensor. It measures more electrical charge and outputs higher value above 80%. This measuring value can be monitored at the control room at real time and can be used as the alarm signal for filter breakage. We will come back to the slide. These are dust monitor model type. First one is integrated type. This is a compact type. Second one is a separate type. When the sensor has to be installed in higher position, it is difficult to set up and adjustment. So the sensor is installed upper place, but controller can be installed at ground level. So it is easier to set up at the ground level by the controller. Third one is high temperature type, which can be used up to the 400 degrees Celsius. We also have an explosion proof type. This is the specification of a dust monitor. Basically, we have a two types, integrated compact type and also remote sensor type. These are the common specifications of our dust sensor. Minimum particle 0.3 micrometer can be detected, and the measuring range has 0.1 through 1000 milligram per cubic meter. This is the integrated type. Power supply AC 80 through 240 voltage and 10 segment LED display. Each segment has a 10%. And it has also the DC4 to 20 milliampere analog output, one output for the upper limit, and one contact output for the fault alarm. This is a remote sensor type. Remote sensor is connected with a controller. Standard 5 meters between the sensor and controller. This wire can be extended to the maximum 100 meters. We also have a high temperature sensor can be used maximum 400 degrees Celsius. These are the controller. This is a common specification among the 3 controllers. AC 110 voltage or the 220 voltage power supply, 2 upper limit and 1 fault alarm, and also 9 level measuring range. KCU11 and KCU12 model has a percentage display. On the other hand, KCU14 has a milligram per cubic meter display. Also, KCU12 and KCU14 model has a correction function. This correction function can make the measuring range get closer to the other reference value, including isokinetic analysis. For example, the isokinetic analysis shows 100 milligram per cubic meter and dust monitor shows 50 milligram per cubic meter. In this case, if we set up the 2.0 times in the correction range, our dust monitor will show up the 100 milligram per cubic meter at that time. After that, it indicates the similar value with isokinetic analysis. This one is a comparison between the triboelectric type and optical sensor. Red line is the optical type and green line is the triboelectric type Matsushima dust monitor. You can find them make the same trend in this graph. Also, you can find the triboelectric type looks fluctuating, but it is actually caused by the higher sensitivity because the dust flow must be different in every second and every moment. So this graph shows that triboelectric type shows a higher sensitivity. Also, triboelectric type shows the same trend with the expensive optical sensor. Next slide is the correlation between the dust monitor and isokinetic analysis. This test was conducted by the fly ash and indicates a 0.969 correlation coefficient, which indicates almost perfect correlation. This higher correlation indicates the almost same trend between these values. Okay, I will summarize the features of the dust monitor. First, it is affordable, which is not expensive, but equivalent performance with isokinetic analysis. Next one is online dust sensor defined by the environmental standard. For example, GIS V8852. Also, it is easy maintenance and easy installation because of the low cost and no technical knowledge required. Next product is our new model, air dust monitor. It can be monitored dust concentration in the atmosphere. It can be used to prevent dust emission, to improve the working environment, and power saving by the controlling dust collectors. This air dust monitor takes the dust from the atmosphere by auto suction and monitors the dust concentration inside this device. One unique feature is wherever the dust can be monitored by this air dust monitor because it is easy to carry and install it. You can find the hand holder for carry on the top. It continuously monitors the dust concentration in the atmosphere 24 hours a day in real time. I would like to explain the configuration of air dust monitor by our demo unit. We will go to switch to our demo unit. Okay, this is our air dust monitor demo unit. This is the intake part, and this is the exhaust part. Open the cover, you can find this is the controller, power voltage supply here, and this is the sensor. I will take out the sensor part here. Inside here, there is a short pipe. So dust is coming from this side and goes through the short piping and goes out from here. And this sensor is monitoring in the middle of this short piping. So this sensor is monitoring the dust concentration and transfer to the signal to the controller. And the controller is converted to the 4 to 20 milliampere analog output to the customer's DCS. We will come back. Okay, we will come back to the slide again. These are the application examples of air dust monitor. We believe it can be applied to the other application for monitoring the environment because it is easy to carry and auto-suction function. I would like to share one more unique application, which is the welding fume application. Welding fume is harmful for the human health, which should be cleaned up for working environment. However, this welding case is one of the difficult applications because of the three conditions is required. First, ability to detect the welding fume. Next, continuous monitoring. Last one is the portability to relocate the monitoring position. When the worker is now working here, if the next working has some distance or different place, this next working condition will not be same. However, it is not the issue anymore because Matsushima Air Dust Monitor satisfies these requirements and works well for this application. If the next work is different place, he can move with the air dust monitor. So the portability is highly useful and protect human health. These are specifications of air dust monitor. The most specifications are the same as the dust monitor, which I explained as the first product. The protection of air dust monitor is IP54 enclosure. It means the air dust monitor can be used outside. Okay, I'll be explain the power concentration sensor. First one is a dust monitor. Second one is air dust monitor. There are many various applications and requests from the customer. We believe that one model cannot be satisfy all of these requests and applications. Matsushima Mediatek designed, develop, and manufacture our original product. We always continue to focusing on the most suitable solution and service to satisfy these all requests and applications. Thank you.
Okay, thank you, Omura-san, for your presentation about dust monitor
Thank you.
and air dust monitor. So let us go through to your questions. Let me see. The first question, the calibration is necessary for your dust monitor. How frequently it should be calibrated? So can you?
Okay.
Okay.
The calibration, yes, it is necessary. That depends on the application and the condition for the customer's cases. But we mostly recommend it once 1 year for the calibration.
I see. Okay. And I want to say that this our dust monitor has less factors to make the signal, for example, like a drift or something, less factor. But recently, many customers have some ISO regulations.
Yes.
Yeah, and they have some internal regulations for the periodical, the calibration for instruments. So, and as far as I know, my case is most of the case 2 years, I think. What about your case?
Yeah, 2 years. Yeah.
Okay, okay. So maybe 1 year, 2 year. It depends on the company's regulation. But I want to say once again, the dust monitor has less factors for signal drift. Okay. And next question is, please send me this document. Okay. We will send. But after this one, we will send the questionnaire. And in the questionnaire, there is a column that you should be describe your email address. So after we receive your questionnaire, then we will send these documents by return. So again, please answer to our questionnaire that will be sent later after this webinar. Okay, next one moment. Tribo electric dust monitor is suitable for liquid chemical industry. Huh. I see. Can you?
Okay. So turbo-electric dust monitor is mostly the most industry can be applied because the point is the customer has a dust collector or customer collecting the dust. So customer needs to monitor the dust concentration before the dust emission. So if the customer, I believe that many liquid and chemical industry has a dust collector. So we have a much potential, even the many industries.
Yes. So this dust monitor is measuring for dust, and any kind of plant, they must have many dust collector. So all those dust collector, our dust monitor can be applied. We hope this answer is.
Yes, we answer it.
What about the moisture content?
Moisture content, too much moisture content, measuring.
I think that one is 40% maybe.
40%.
Yes. So if the moisture content over 40%, may be problematic. So yes, I want to add this condition. So next question is, how long maximum distance between sensor and display unit?
Oh, this is for the separate type.
I believe yes.
Yeah. Separate type, the sensor, and we have a sensor and a controller. Standard type is a 5 meter, and maximum is 100 meter.
Okay. Okay. Next question is there separated unit between sensor and display unit?
Separate unit, sensor and display unit.
I think this is the question. If this question is asking whether we have separated unit, remote model. In that case, we have. So if our understanding for your question is different, please send me.
Yes.
Maybe you can use this chat or something. Next question is this equipment should calibrated periodically? If yes, how many time calibration must do per year? Huh. Okay, can you?
Calibration?
Calibration.
Calibration,
Periodical calibration.
Yes, periodical calibration. We just answer just 1 year.
We answer for the first question.
Yeah, first
I
question.
think yes,
maybe
same
similar.
question. So again, please.
Okay. Yes. Our dust monitor is calibration is necessary. That depends on the customer's case, but we recommend into the once a 1 year or once a 2 year. That depends on the customer's regulation.
Okay. Many questions. The question is over 20. So we will try our best to answer within the one by one within the time. So next question is, how long is the lifetime of dust monitor?
Lifetime. Okay. Our dust monitor is designed for mostly the 7 through the 10 years. This is a lifetime for the main signal processing, the electrical parts.
Okay. So next question, the duct diameter has 2 meter length. Is the standard probe length applicable?
Okay. Duct diameter is 2 meter. And our dust monitor is standard is 300 mm. Most application, if our dust sensor is installed to the proper position, we can say yes. Most application, our standard 300 mm can be covered. The point is what is the we can say the stable and even flow position. So no turbulence, and we strongly recommended the straight portion, no light after the draw, no light after the bending portion.
Yes. Okay. And I think this is also the issue about sensitivity.
Yes, sensitivity.
Yeah. So, for example, okay, if you have some very poor triboelectric system, probably you need longer probe to get more information from dust. But actually, our triboelectric dust monitor has like a very sensitive because we have AC/DC system. So actually, for 2 meter duct, you can use 300 mm triboelectric dust monitor because our triboelectric dust monitor is very sensitive. And most of all of triboelectric system is relative value measurement. So in this case, the important issue is like a sensitivity. And if some company said, oh, the probe should be 1 meter or something, it means this triboelectric has less sensitivity, I believe, yes. So next question, because air dust monitor is portable, the power supply line not required?
Oh, I see. At this moment, our air dust monitor needs power supply line, AC 100 or the AC 200. But our R&D team is trying to develop and design the other type of the power supply. For example, solar, for example, battery. I hope near future
yes. Should become earlier. Okay. So next question is, what are your major target segments for dust monitoring?
Major target. Oh, it's a difficult question. Major target is.
Can I answer? Okay. So one is like a continuous emission monitoring. This is for big stack. So this our triboelectric system can be applied for continuous emission monitoring, but most of the case, the most popular application is the performance monitoring of bag filter, and for bigger one, like industrial big bag filter is the most popular application for us. But we also have many experience for like electrostatic precipitator for power plant and paper industry as well, and the stack emission monitoring for stack, and small bug filter also okay. So everywhere, okay. Okay, so we have less time, but let us try to a few more. About calibration, we have to return sensor to Japan. Is it correct? Huh.
Actually, we have a calibration kit. So that depends on the customer's request. Of course, customer can return back to the dust monitor, return back, and we can check and calibrate everything, and we can return to the customer side. And if the customer requesting to do the calibration at the customer side, we can bring. Or some our agent has the ability to the calibrate, and maybe our agent go to the site and they do the calibration.
Okay. In the meantime, the question is increasing. So I think there is we don't have enough time to answer all those questions because question is over 40 now, over 30. So thank you so much. I think it seems it's time to finish the webinar. And all those questions remained. We will send you the we will make some question and answer table, and we will send it to you later. But before that, again, we will send questionnaire. So please kindly answer to those questionnaire together with your email address. Then we will send our documents and also the answer question and answer table later. The questionnaire it takes only a few minutes, so please. So, okay, again, thank you so much for joining to our webinar today. So we will try to improve our service more, and because under this type of situation, we also have the web seminar and web meeting. And if you want some documentation, we will immediately make and send it to you. So please feel free to ask us any question and requirement. We will try our best to support your business and your operation. Again, thank you so much for joining to our webinar today. We are really looking forward to serving you in the near future. Thank you so much again for today.
Thank you.
Bye-bye. Bye-bye.
Thank you.